Alright, hi everyone, welcome to my YouTube channel City of Electrons, and in this video we are going to do this, okay, the concept of bus and some Arduino microcontroller functions, okay, with their commands, microcontroller function. Remember that project we did, that intruder alarm we did. So there are some things we used, which is this. We used something like this void setup in our code, and we used this pin mode, and we used the digital write. Okay, see, we made use of all this. Analog read, did we? We did not make use of analog read, but I will explain what it means in this video, even if we did not make use of it in that project, that simulation. So, but the first thing is this: what do we mean by bus? The idea of a bus. Again, we've done that in this video. Now, this is just a block diagram of a microprocessor, and we can see that in here we have note, we are still working on past questions. This video is still on a past question, okay, and it just what we are working on. What we are working on is this, okay. What we are working on is this. That is to describe bus concepts, okay, of microcontroller. What we mean by bus. That's what we want to do here. And after we do that, which is this first part, okay, then the other part is to explain this. That is this Arduino programming structure. Okay, explain the following functions in Arduino programming structure. So, what is the bus concept, and then this explain this. So this is still part of the past question. Okay, so that's what we're doing now. Now, for the bus concept, look at this. Look at this. So we see this is a block diagram of the microprocessor. Okay, of a microprocessor, and in this there are different components. What links each component? What links one component to another component? How is data transferred? Okay, moved from one place to another. These lines, they are the buses, like motor, car, okay, vehicle. Yes, let me use that word, vehicle. Okay, so a bus is a collection of wires. You see what I just, like the previous slide, collection of wires, conductors, used to transfer data between various components. Now, there are three main types of buses. Data bus, okay, this one carries data. Address bus, this one carries address of data. And then control bus, which carries control signal to coordinate activities in the microprocessor. Now, okay, so for data bus, it carries data. For example, this in the ALU here, when it operates on data, the data is carried from this ALU to the accumulator, okay, to the accumulator, like stored there, the accumulator. So this bus that carries data is called data bus. That kind of bus that carries data, okay, just like saying it's a vehicle, and this vehicle carries people. So people vehicle, people bus. But if the is meant to carry, let's say cars, different things, but not human, then it will be called cargo, okay, things like that, cargo, shipping and things like that. Not cargo plane does not carry people, it carries things, okay, objects, properties, load and things like that. So you get the idea. So with that, data bus carries data. What about address bus? Just like the name, it carries address of data. So data are stored in memory. Where in the memory? That location in memory, that address of the data is carried in a bus, and the bus that carries that address is known as address bus. Okay. All right, now Yeah, so that's for that. Okay, then where are we? Okay, here. Now looking at this, that's just the concept of address bus. Okay, there are 3 main types of bus. The data bus carries data, the address bus carries address of data, and then control bus, the control, that is what should be executed, is carried in the control bus. Look at this guy here. Look at this guy here. Now the timing and control unit, the instruction to do something, that instruction is carried in the control bus. Okay, that's just the idea there. All right, now so that's the idea for this bus, the idea of a bus. Then for some Arduino functions and command, this is the next in the past question. Okay, to explain what is the meaning of void setup, what is the pin mode, what is digital write, explain and then give example of them. Okay, so I have an example here online in this website Tinkercad. I think the last time I talked about using a website Walkway. Okay, website Walkway, yeah. So I use Walkway and Tinkercad. There are some things that are available here on Walkway, and there are some things that are available here. Okay, so let's just run with this. So whichever one you like, you can just make use of them. Now looking at this, this is for controlling these 2 LED using potentiometer, controlling the duration at which they blink. Let me just simulate and so you see what's going on. Okay, yeah, you can see how they blink. Now if I change the potentiometer value, the value of the potentiometer is used as the delay. Okay, so if you look at the code now and you check the serial monitor, you see okay, now this is the value of the, excuse me, okay, now this is the value of the potentiometer. When we change the value of the potentiometer, you can see that there will be a change here. You see that now it's smaller, it's less now, less than the previous one. So less value of the potentiometer, it means it will blink faster, it will change faster. Higher value of the potentiometer, it will change, like it will take time, more time to change. So we are using the value of the potentiometer as the delay for these guys. Now the main thing I want to show you here is these keywords and functions in Arduino, which is this pin mode. What is pin mode and how is pin mode used? Then what is the other thing said in the equation is what is digital write and what is analog. I think let's just check it. What's digital? Okay, what's voice setup, pin mode, and then digital write. I think there's other one, analog read. Yeah, analog read. So we have all those examples. We have all those things here in this program. Okay, in this example. So let's go. Now the first one is what they mean by void setup. Now this is a built-in function that allows programmers to set up initial states of the Arduino once it starts or resets. Okay, so it's to set up the initial state of the Arduino once it starts or resets. So it runs once, and it is where we set pin mode and establish communication with the Arduino. Now this is the example how it looks like. Void setup, you say pin mode 13 or 14 or 13 or 12 or whichever pin number from 0 to 13, and you say output or input. Now this sets the pin 13 as output pin. Look at this example right here. Now we have this, and if you look at this double slash just means comment. Okay, so you have this part of the code. This is not what we are talking about. Next part, this part of the code, this is where we are talking about when we say void setup. So the void is a function. The void setup is a function that returns nothing. So we say the data type of this is void. The type of data it returns is nothing, so void. it returns nothing. There's nothing like return 0 or return whatever. So we say void. This setup is just the name of the function setup. Now this function is used to declare what you want the pin to do. To declare like not just to declare the pin, but to set your Arduino. It's just like the name, set up. Now you can see that these pins here, look at it, digital, okay, digital, okay, pulse width modulation, but these are digital pins from 0 to 13, but we use from like 2 to 13. Now these are input output pin. Should it be input, you will decide here. Should it be output, you will decide here. But in this case we are sending oh boy, too small. But in this case you can see that we are sending, look at this wire now, both of them goes to the LED, to LED. So we are giving signal from the Arduino to the LED. That means they are output. So, and you can see that both LEDs, one is connected to pin 12, one is connected to pin 8. So let's get closer. Okay, this is better. So you can see pin 12, we say that one should be LED 1. Pin 8, that should be LED 2. Okay, so LED 1, which is pin 12, should be output. LED 2, pin 2 should be what? Output. Meaning we are setting the Arduino, saying that what happens to pin 12 and pin 8 is it should be output, because this line can either be input or output. But now in the setup we have said it should be what? Output. So it's our choice. Now with this explanation, I have given you the idea of what setup means and even what pin mode means, because that's the next thing. Yeah, what pin mode means. So it's a function used to assign digital pins to act as input or what? Output. It takes two arguments, the pin number and then the mode. Now these are the arguments. Two arguments, this comma this. What is here is what? The pin number. Remember we have said LED 1 should be given to what? Pin 12. So it's like saying what we have here is pin 12. Okay, and then it takes the pin number, which is this pin 12 or whichever pin, and then the states. It should be should it be input or output? So here we now select the name, select the type. Okay, so that's for that. And then digital write. Now this function sends high, which is 5 volts, or low, 0 volts, to a digital pin. Look at the name, digital. Remember, write means to put in, read means to take out. That's to get data from somewhere. That's read. Write means to put in data. Okay, so this turns on or off the load, LED, motor, buzzer, whatever, etc. So for example, we have this. Let's go to our example here. So now that happens in the void loop. Okay, that happens in the void loop, in the loop function. Where is our any digital read, digital write again? Good. Now digital write, meaning this LED, which is pin 13, this digital write is a function that also takes two arguments, the pin number and then the states. So this is that's pin 12. That's what we said in this code, pin 12. Okay, for LED 1, pin 12. Why pin 12? Because we connected pin 12 to this, the LED to pin 12. If we put it in another pin, then we have that pin number in the code, just like that. So yeah, so digital writes. So in pin 13 we are saying the Arduino should send high, like 5 volts, send voltage there. That's what we mean. Okay, similarly, if we say digital read, it means we should get value from it. But since this is output, we are going to write to it. That's why we are saying digital write. And it's a digital pin. Look at it. D, digital 12, D12. So it's a digital pin, so digital, right? Then for the next one, I think that next one is analog read. And for analog read, it's similar to the other. However, in this case, it's analog pin, not digital. Look at it here. Look at it here. I'm trying to zoom out. Okay. Yes. Just give me a second. Yeah, look at it. A0 to A5. So these are the analog pins. So just like the digital pin, you say because it's digital, you write digital. This case, because it's analog, you write what? Analog. I think I have an example there. I did that in this. Yeah, look at it. Analog. So the potentiometer which will connect to this analog pin here, A0, we are going to say we want to get that value. When we tune the potentiometer, it will send a value to this guy, to this pin. We want to get that value from that pin. So we'll now say analog what? Read to get the value. Now, port pin. This is pin A0. Why? Because we have said in our code, we have written it before, that A0 should be assigned to port pin. So whatever that's in A0 should be assigned to port pin. And what we have in that A0, in order to get it, to use it, to read it, we say analog read. Analog, why? Because it's analog pin. Read because we want to get something from it. And we put the argument, which is the pin number. And then when we get that value, we assign the value to another variable. And we just call it port value, which is potentiometer value variable. This variable, we have declared it here already, saying it's an integer, int port value. And here it has no figure, nothing attached to it. But here we now attach something to it here, right here. Okay, so that's for the analog read. I guess we are clear with that. Okay, so that's all. Okay, with that. Okay, now another thing in the past question is this: difference between microcontroller and microprocessor. So this one is just clear. I think it's really clear, because for microprocessor, first, before we read these things here, let me just show you what it is right here. Okay, so code off. Yeah, now look at this. This is the microcontroller, but how do you connect things to the microprocessor? You need the microcontroller, of which the microprocessor is placed in to the microcontroller, so that when you connect things to the when you connect things to the microcontroller, it is connected into the microprocessor. So the microprocessor is just the brain, or you can say the heart or brain, and then the body, the body acts as part which is connected to the brain. Okay, the body, let's call this one the body of the brain. For us to interact with the brain, we need a body, that kind of thing. Okay, I hope we just get the picture. Okay, I hope we get the picture. So a microprocessor is primarily a central processing unit that requires external components like RAM, ROM, and input and output ports to form a functional system. This microprocessor here cannot function on its own. It cannot function on its own. There is no USB port. If you remove this black guy here, the microprocessor, it doesn't have a USB port. It doesn't have a button you can press for reset. It doesn't have a RAM. It doesn't have those things. Okay, so in order for us to have those things, like function, have those things together with the microprocessor for a functional system, we need this microprocessor to be placed inside a microcontroller. Okay, so we can access all those other functions. Are we together? So yeah, now they are designed, that's microprocessor, they are designed for general purpose computing and handle complex tasks as seen in devices like modern PC, Intel Core i7 processor. Now in contrast, a microcontroller integrates the CPU, memory, which is RAM, ROM, and then flash, and input and output peripherals all onto a single chip, such as 80 mega 32 HP, which is found in Arduino boards. Now look at this. Okay, so this is the 80 mega, okay, and 32 found in Arduino board. Okay, so the microprocessor is inside this. It's inside this. Are we together? Okay, the microprocessor is inside this. This is also part of the microcontroller. This is also part of the microcontroller, but the microprocessor is inside it. Are we together? Good. So I believe that clears the difference between microprocessor and microcontroller. So now for input and output device, on that part of the past question asks for us to state input and output device, mention input device of the microprocessor and mention output device of the microprocessor. And I think this is clear enough. Motion sensor acts as input. Motion sensor gives input, detects movement by sensing infrared radiation. Ultrasonic sensor also acts as input. It measures distance of an object by emitting and receiving sound waves. Keyboard also acts as input, allowing alphanumeric data input from user. Mouse also acts as input, also a microphone. Okay, you can list more in the comment section. And then output device, of course, buzzer and speaker gives you audible tunes. Okay, LED, light emitting diode, gives you light, serves as indicators. Then relay module acts as electrical control switch to turn on high power devices. Okay, then device and DC motor, LCD display, all these are output device, okay, or devices. So output device, input device of the microprocessor. Okay, so the next thing in the past question. All right, some special purpose microprocessor. Now we're asked in the past question to talk about difference between CISC and RISC. Okay, and then, or let me just go with this one first. Special purpose microprocessor. So for special purpose microprocessor, these microprocessors are specialized for particular tasks. Okay, processors for particular tasks. Now 3 are just listed here. One is embedded microprocessor and is designed to perform a dedicated function within a larger system. They are typically low cost and optimized for specific control application. Embedded microprocessor. So the next one is DSP, which is digital signal processor, and they are optimized for high speed mathematical operations, specifically for processing real world analog systems, real world analog signals converted to digital form. Now they are also used in audio, video, and communication systems. See, most real life or real world signals are in analog form, that is continuous. Okay, continuous. Then this DSP is used for this DSP is specially for processing real world analog signals converted to what? Digital form. Digital form, that is discrete values. You have a value here, a value here, a value here. Let's something like this. Okay, then for digital it will be this. You have a value like this, like this. Okay, are we seeing that? For analog is continuous time. For digital, discrete time. Okay, so that's just for that. So converting this analog towards digital, working on signals that has been converted from analog to digital. So this digital signal processor is optimized for that. Okay, then the third one is graphics processor, GPU, and this GPU is specialized for rapid parallel processing to render image, videos, and animation for display. Okay, their parallel architecture also excels at massive parallel computation for AI and scientific tasks. So of course this your games and things like that comes into play in this case for graphics processor. Okay, so yeah, so that's just some special purpose microprocessor. Okay, then for the difference between CISC and RISC, note CISC is complex instruction set computer, RISC is reduced instruction set computer. So we are going to differentiate them using the different features. Okay, so in terms of instruction sets, CISC is large, complex, and varied, while RISC is small, simple, and optimized. Are we seeing the comparison? Okay, then in terms of instruction length, CISC is lengthy. Okay, and its length is not really constant, it's not fixed, it's variable length, while for RISC its length is fixed. Okay, fixed length. Then in terms of clock cycles per instruction, for CISC you have multiple cycles per instruction, while for RISC you have single cycle per instruction. For pipelining, man, CISC is difficult. Okay, for pipelining, while RISC is easy and highly efficient. Then in terms of register count, CISC has fewer general purpose register, RISC has more general purpose register. Okay, then the last part of the past question is bus organization. That's the last part of the past question. Okay, so bus organization. Now we have the concept of dedicated bus and multiplexed bus. Okay, dedicated and multiplexed bus. Note that this is just a simple diagram which we have drawn again and again. Okay, showing you different how buses move from different components, how buses connect different components together. All right, now the concept of dedicated bus and multiplex bus. For dedicated bus, it has individual lines permanently assigned to a specific function, like separate line for data, separate line for address, separate line for control. We talked about this right here, where we said that we have a data bus, control bus, and a address bus. Also, now those three type of buses, you can have separate line for each type of bus. Are we together? Now this allows for simultaneous and faster transfer, but uses more physical connection. If we are using a separate line for data, address, and control bus, it means while we are sending data, we can send address and we can send control at the same time, parallel, simultaneously, because we have separate buses for the separate bus for the separate type of content they carry. Okay, while for multiplex bus, so that will allow us to carry out that instruction simultaneously. However, we will need more physical connection, since a separate bus is for separate type of content. We need more connection, more physical connections. But for multiplex bus, a multiplex bus uses the same set of physical lines for multiple functions. Now this is what we mean. So this one carries address, that bus carries address of data, this bus carries that bus carries the data, and then another bus carries what? Instruction. Are we seeing it now? That one carries instruction, this one carries data, and this one carries what? Address of data. This is for this is not for complex, okay? That's not for, that's not for multiplex bus. That is for what? Dedicated bus. But for complex, for multiplex, how am I saying complex? For multiplex bus, let me use a different color. For multiplex bus, this same bus carries control. This same bus carries data. This same bus carries what? Address of data. Now, because of this nature, you can see this one is for what? This one is for what? Dedicated bus. This one is for what? Multiplex bus. Now, you can see that in dedicated bus, we can send address, we can send data, we can send control at the same time. But we need more physical wire. Now we need 3. We need more physical connection. But in dedicated bus, in multiplex bus, we need less physical connection. Just a single wire can carry data, address, and then control. However, we can only send, when we are sending data, we are not sending control, we are not sending address. When we are sending address, we are not sending control, we are not sending data. So it reduces what we can do at a particular time. Are we seeing it now? Okay. So a multiplex bus uses the same set of physical lines for multiple functions, typically sharing them for both address and data at different time. Did I mention at the same time before? Please, it's at different time, because the time you are sending data, that time you cannot send address. So it's at different time. You send a particular thing at one time. If you want to send another thing, you have to wait till you are done with the current one. So this reduces the number of physical connection, but requires time sharing and more complex control logic. So that's for dedicated bus and multiplex bus. Now, I know I'm saying a lot in a single video, but we are just trying to cover the past question. Okay, I'm just trying to cover the past question. So, that's what we are trying to do. So before we even hit on advantage and disadvantage of parallel and then what? Serial bus system, understand this, that for parallel bus system, it's a system where information, information which is bits, let's say 1011, okay, this simple information, okay, information. Now this information is in bits. This is 4 bits and data. Now if we want to send it through parallel bus system, each bit will have its own line. Okay, each bit will have its own line. Line 1, line 2, line 3, line 4. Okay, so 1011, so 1011. Are we seeing it now? This is for a parallel bus system. But for a series bus system, we are using just one line. Just one line. So it will be 1011. But for parallel, it's 1011. I hope you get the picture. Okay, so now we can talk about the advantage and disadvantage of that. Now, for parallel bus system, the advantage is that it has high speed because it transfers multiple bits simultaneously. Are we seeing it now? Then for the another advantage is that it's used simpler logic. Okay, then the communication is direct communication. Then instant data, all bits arrive at the same time. Okay, like the delay is negligible, the delay. Then less protocol overhead. Let me see, often require less complex communication protocols since we are sending each bit per line, okay, or per bus. Yeah. So the disadvantage is that you need more wires. Obviously, looking at it, you can see that you need more wires. For serial, you just need one, less wire. This guy more wires. Okay. So you need more wires, and they may be crosstalk, meaning signals
interfere with each other over longer distance. Okay. Then limited distance, meaning performance degrades significantly over longer cable lengths. Then higher power consumption. Of course, more lines switching consume more power. Okay. So yeah, of course, now because you have current flowing through each line. Okay, while here you have current flowing through just one line. So of course this one take more power, this one take less power. Okay. So yeah, that's for the disadvantage. Then for serial bus advantage, fewer lines, that is obvious, fewer lines. Then longer distance, meaning less susceptible to signal degradation and skew over long distance. Now remember, for the disadvantage we made mention of I think I didn't talk about this, but it's there. Disadvantage of the parallel bus: signal skew, meaning bits can arrive at slightly different times, causing synchronization issues. Okay, so when you send, that's the disadvantage of this guy, when you send them over long distance, these bits, this is one information, but because of the longer distance and they have one wire dedicated to one bit, they may arrive at the destination at maybe little difference in time. This one may arrive maybe earlier than this or something like that, causing synchronization issues. So that's a disadvantage for parallel. But for serial bus, it is not a disadvantage. In fact, it's considered as an advantage. Okay, because it doesn't have that issue. Okay, longer distance doesn't have that issue of signal degradation and skew over long distance. Then less crosstalk, there's less interference between signals. Okay, you can see for this guy there can be interference because line, same information, there can be interference, but for this guy there is no crosstalk, no interference. You can see when they say crosstalk, cross interference. You get the point? Okay, so less crosstalk, and this one consume less power. That's for serial bus, consume less power because it's just a single line. Then smaller connection because it's just a single line or smaller connectors. Alright, then the disadvantage: low speed. Have you seen it? Bits are transferred one by one, making the base speed slower. Then complex logic, of course, because we are using one line for all the bits, the logic will be complex compared to when we just spread all the bits to different lines. Okay, saving us the logic. So since we are using all bits in one line, it gives complex logic. Okay, then higher latency. Individual bits experience higher latency due to sequential transfer. That is, one bit goes, another bit comes. Like one bit have to wait for the previous, and the arrival time of the first bit, the arrival time of the last bit will depend on when the first, the second and third bits get there. So the fourth bit, we have to wait for all the other bits, first, second and third, to get there first. So you see, higher latency. Individual bits experience higher latency due to sequential transfer. Then clock recovery. So it often requires sophisticated clock recovery mechanism for synchronization. Okay, then higher processing overhead, more processing required to pack and unpack data. Now well, we have the data, this data information, we have to take them through one line, unpack, and they are sent 1, 2, 3 for one after the other, and then when they go through, we have to pack them back. So they are pack and unpack, that kind of thing. Yeah, or you pack, you send, you unpack. That pack and unpack is kind of processing overhead. Okay, so higher processing overhead. Okay, so more processing required to pack and unpack data. Okay, so you can just, if you want to maybe screenshot or something,
so you can read this thing over and over again and get to know them for yourself. Now whichever one you feel like, oh, you can't really relate with this, it doesn't really make complete sense to you now, no big deal. Okay, just read them, go through over them again and again, and then you get used to them, and with time they will make more sense to you. Okay, now this is just a simple diagram of the of the microprocessor. Okay, and this is a more complex diagram of which you can find online and browse. Block diagram of the microprocessor. Okay, so with this we are done with the past question. Okay, so like, share, subscribe, comment, and then click on the notification bell, so I will upload the video next, you get to see it on time. And then I think that will be all for this video. Please comment. Okay, note I'm a student here, I'm still a student, so comment anything you need to point out, please do. And thanks a lot for watching. Bye for now.